Hey guys, it's Julie and I'm going to talk about variable scope in C++ programming. In this video, I'm going to first define scope, talk about how it works with local variables, what happens when we have variables with the same name, and then finally this idea of global constants. So a variable scope just means the lifetime of a variable or constant. So when was it created? When is it destroyed? And which parts of the program have access to it? And most of what I'm going to discuss here is using examples with variables, but this applies to constants as well. And when we're looking at the scope of a variable, the scope is going to be often the variable inside a code block. And a code block is just statements that are enclosed in curly braces. So it can be a function body, like the main function on the right. That's a code block. It can be a branch with an if, else statement. Each branch can be in a code block. Or it can be the body of a loop, like the loop on the right-hand side. So the program on the right-hand side has two code blocks. One code block is inside the other, the while loop, and everything in the while loop has access to the variables that are inside the main code block. So we can define the variable count inside of main. Then when we embed another code block, our while loop, in main, it also has access to our variable count. So what does it mean with a variable's local? Most of what we create are local variables. And that's when we're creating a variable inside a code block. It's only going to be accessible inside the block where it was created. And when the code block ends, that variable is going to be destroyed. And if we were to go and execute that code block again, the values don't persist and we aren't going to know what value it had the last time we executed that code block. It's going to start over from the beginning. Now, one place we'll often define a local variable is in the heading of our for loop. And so a lot of people will define an iterator variable inside the for loop. Like I have here, I have an integer variable I that I am defining and initializing to 0. And I'm using this iterator variable to control my for loop executions, each iteration. That variable I belongs to the for loop code block, or the body of the for loop, and the body of this for loop has access to I, but as soon as the for loop finishes executing, that variable I will be destroyed and is no longer accessible. So what happens when we have variables created with the same name? Well, in this first example, I have a main function where I created variable x, an integer variable, and initialized it to 5. I'm going to call a function, and then after the function returns, display the value 5, or value of x, which will be 5. Now in the printDouble function, I also have another variable, and it happens to be x as well. But this is a separate variable. I can initialize this x to 10, modify it by multiplying it by 2, and when I say cout x inside the printDouble function, I am displaying the value of x that's local to that function. I don't have access to the x in main, I only have access to the x inside this function. After printDouble finishes executing, main's going to display its value of x, and it is not impacted by anything that happened in printDouble. So we have two code blocks, each has a variable named x, but the statements inside the printDouble function have no impact on main's variable x. And after we execute this code, we'll see the output from printDouble, which was 2 times 10 or 20. And then we'll see the value of x in main, which is unchanged and still 5. Well, these are 2 separate code blocks that each have a variable that coincidentally has the same name. But you can do other things that are confusing. And in this example, I have a for loop embedded inside my main function. My main function has a variable named x, but in my for loop, I'm going to create another variable named x, as well as a variable named y. And this variable x and y, these are local to each iteration of the for loop. In fact, each time the for loop executes or iterates, I'm going to create an x and a y, manipulate them, and then as soon as that iteration ends, that x and y will be destroyed. And then I'll create them again with the next iteration. So the inside x and y are actually created and destroyed 10 times. But one problem I have here is I have used the same name, x, both inside of main and then in the embedded for loop. And this is not a good idea because now I no longer have access to the x in main, the first x that was defined, and it's very confusing to understand and to debug. So this is not a good way to write code. Instead, if I needed to create another variable inside the for loop, I should give it a completely separate name in this situation. So, what happens when I create variables with the same name? If the variables are in separate functions, they're completely independent variables, and that's fine. There's no problem with that. But if I have 2 variables where, for example, one's created outside of a loop and one is inside a loop, these are independent variables, but now the outside variable is not accessible to the inside of the loop, and it's very confusing. This is not a good programming practice. And finally, I want to talk about the idea of global variables and constants. So global is the opposite of local. Global means it's accessible to everything. And when we create a global variable or constant, it's going to be defined outside of all functions. It will not be in a code block. And its scope is going to be from wherever it's defined to the end of the CPP file. It's often defined before main, and it's going to be accessible to all of the functions in that file that are defined after the global variable or constant. Now, if we're working with constants, that's okay to do because a constant is something by definition doesn't have a changing value. And if we were writing several math functions that worked with pi, it would make sense to create one constant named pi at the very beginning of the file and not have to create more constants named pi inside of each function. But if we're creating a variable, we never want to create a global variable. All of our variables need to be created inside of some code block, inside a function or a loop or something like that. Creating global variables is bad programming practice. We want to never create these. And when you write a program, if you feel like you need to create global variables, then step back and think about a different way that you could design that program, because there's probably a better way to do it. So, in summary, we talked about what scope means, the lifetime of a variable or a constant. And most of our variables and constants are going to be local. They're defined inside a code block. And when that code block ends, their scope ends and they go away. We also talked about global variables and constants. These are defined outside of all functions, and this is okay for constants, but not for variables.